Hello, good morning, Eugene. Morning, morning. We wait until about 2:05 like that, okay? We see whether got other people joining or not. Because we also don't know how many people will join. Just now morning class also very few people. Morning, you will go for chemistry or not? Okay, okay. Dapat. Okay, I guess just you for now. I think some of them will join later also nah. Just now also, after 10 minutes, still got people join. After 20 minutes, still got people join. So I think some of them will join maybe later. Okay, never mind. All right. You got the notes already, yeah? Got the notes or not for the seminar one? Or you use a PDF? Got got the physical notes don't waste since it's free one, just request only. Okay, so if you look at the notes, right, you will notice that the whole notes only got one chapter only, right? Yeah, the whole notes only got one chapter only, which is the Form 4 chapter 6, light and optics. Okay, so because right for this seminar we don't want to what do you call this? We don't want to do Form 5 topic because Form 5 topic, I mean, in normal class, the notes, that one already got Form 5 topic revision already. Okay, so that one we don't want to do. Then for Form 4, right, if we, let's say, like we ask students lah, okay, most of the students, they will prefer to do revision for chapter 6 lah. Okay, so that's why we mainly focus on Form 4 chapter 6 only lah. All right, for this seminar. Okay, yeah. So now for this Form 4 chapter 6, right? Mainly there are three types of questions lah. Okay, mainly there are three types of questions. So we have a drawing type question, we have a calculation type question, and we have the explanation type question. Okay, now for these three kinds, right? Drawing, calculation, and explanation, which one do you think you are most confident with one? Like which one do you think you will have a highest chance to score? Drawing, calculation, or explanation? For this chapter only, this topic only. You don't compare other topics, just compare this topic only. Which one do you think you will have more chance to score? Drawing easier lah, huh? Okay. Now, your drawing, right? Do you think is 100%? You can draw like 100%, no problem? Guarantee? Haven't do much calculation, Okay, right. Later we will do calculation. Okay, later we'll do calculation. Sorry, give me one moment. Okay, so we will do calculation also, but I just want to know whether your drawing, like, you 100% okay or not. Like if you are 100% okay, then we don't need to cover any drawing already. But if let's say your drawing is like, let's say 70-80%, then we will do drawing just to make it to 100%. So I want to like guarantee your drawing always you can get full marks for your drawing one. Yeah lah. What do you think? Hmm? What do you think? You think okay, can Okay, then if you're confident, right? Then never mind. Then we will skip the drawing part lor. So today we focus on calculation and explanation question lah. Okay, right? So I will start off with calculation first lah. Okay. All right. Now for calculation, basically, right? We have actually mainly only got two things that involve calculation only one. The first one is refractive index. Okay, so anytime you see refractive index, you see the word and, okay, that one is one of the calculation. Okay, basically is how much, how much the light will bend when it goes into something else. That's called refractive index. Okay, so this calculation, right, you don't need to worry about the formula because in your formula sheet, they will give you all. Okay, they'll give you all, but you need to know what are these things. Okay, like you need to know what is C, what is V, what is I, what is R, what is this C, what is H? Okay, so all this you need to know lah. Okay, so let's start from there first. Now, the first one, the first formula, refractive index is C over V. Okay, this C is actually the speed of light. Okay, the speed of light. So, like speed of light in air, in vacuum, the fastest speed of light. Okay. Oh, hello, welcome, welcome. Welcome, Gatlin. Okay, we just started not long ago only. Okay. Right now we're talking about the formulas for light and optic. Okay, so C is the speed of light in air, in vacuum. So this one is basically the fastest ever speed that we know lah. 3 times 10 power of 8. Okay, this one actually also given in your exam, I think. Yeah, here, you see? Is given one. I mean, they will give you this number lah, 3 times 10 to the power 8. Okay, V will be what? V will be the speed of the light inside whatever lah. Okay, the speed of light inside water, the speed of light inside alcohol, the speed of light inside what else? Diamond, the speed of light inside glass. Okay, so all these things, yeah, that's the speed of light inside all these things, we call that V. Okay, all right. Now the next one is sine I over sine R. Okay, sine I over sine R. This one, I want you to take note. Okay, you can write it down in your notes here lah, because there's a sine I over sine R. So I think, this one, page number 4. Sorry, this one is just now that one. Okay, page number 4. You see, page number 4. This sine I over sine R. All right, I want you to write down. This one must be big angle. This one must be small angle. Okay, big angle on top, small angle at the bottom. This one is fixed one. Okay, it's fixed one. I don't care what they write in the question. Okay, I don't care whether they say, okay, let's say there's a light coming out like that, and then they tell you this an I, they tell you this an R. Okay, so you still put this one on top and you put this one on the bottom. Why? Because this is the big angle. This is the small angle. Do you understand or not? Okay, so make sure you don't follow blindly the I and R. Whenever you use this formula, it must be big over small. Okay. All right, and then the next one is 1 over sine C. This C and this C, not the same. This one is where it gets a bit confusing lah. This C here is critical angle. Because when you use sine, it must be an angle ma. You cannot sine a velocity ma. You cannot sine the speed of light. It's impossible one. Sine, tangent, cos must only use for angle. So this is called critical angle. Okay, every object has their own critical angle. Water got their own critical angle. Okay, this what do you call this? Glass got its own critical angle. Diamond got its own critical angle. Yeah, so you don't have to this one you don't need to worry like what is what lah. You just remember this is called critical angle. Okay. Now the last one, capital letter H over small letter h. Now capital letter H over small letter h is depth. This is real depth. Okay, this is apparent depth. Yeah, the object, right, in water is always deeper than what you see. You see the object here, but the object is always deeper. So this is what we call real depth, the capital letter H. And this is the apparent depth, the small h. It looks like that. It looks like it's a higher up. Okay, right? Okay, so any questions about this 4 formulas? Any questions about these 4 formulas for our calculation? Okay, Ken, all good, Okay, Eugene, good? Okay, Hello, welcome, Annie, good morning. Why so late? Why so late? Just had lunch. Okay, all right. Now, so okay. No problem. I'm still explaining the formulas only right now. Okay. All right. So that's the first thing that we have calculation. Yeah, in this chapter, that's the first main part for calculation. Okay, the second part with calculation is this one, length formula. That's the second part with calculation, length formula. Now, the length formula, right, is quite straightforward. 1 over F equals 1 over U plus 1 over V. In case you don't know what these things are, F stands for focal length. U stands for object distance. And V stands for image distance. Okay? Yeah? Focal length, object distance, and image distance. Wait, Snell's law uses the big angle for incident ray every time. Yes, if you are doing sine I over sine R, yes, the big angle must always be up there. Okay? The big angle must always be on top. Yes. Because you see N refractive index the number is always 1 point something or 2 point something or what one. The number must always be bigger than 1, you know? So you cannot get bigger than 1 if you have a small number on top. In order to get bigger than 1, the big number must be on top, the small number must be at the bottom. Correct? So that's the reason why lah. Okay, that's the reason why. Yeah. Okay, so this one cannot focal length, object distance, image distance okay. Now the hard part about this length formula, the part where many students get wrong is these formulas, these things can have negative number. Okay, that is a big problem for most people. They don't know when should you put negative number, when should you put positive number. Okay, so let me explain to you how to know when to put negative and positive. Okay, first of all is the focal length. Okay, you all know what's focal point, right? You all know what's F? Yeah, if you have a lens, right? And then there is like a F, like that, correct? Okay, so let's say this is a convex lens, okay, convex lens. When the light ray shine through the convex lens like that, what will happen? When you have all these parallel light rays, they go through the convex lens. They will converge to the F. Okay? They will converge to the F. They will focus at the F there. Correct? Okay? So that means the light actually got passed through the F1, you know? The light got passed through the F. The light actually got used the F. So that means this F is a real F. Okay? This is a real F. So that means this focal length is positive. Okay? Real means positive. Virtual means negative. Okay? Now, if let's say I have a concave lens, yeah? Do you know what the concave lens will do? Do you know what the concave lens will do? The concave lens, right, will spread the light out. Okay? Concave lens will spread the light out. Yeah? So when that happens, right, none of the light pass through the F. Even though we say, hey, you trace back this light, actually it will go through the F1. You trace back. But then it doesn't really pass through the F1, It doesn't really pass through. So this one is fake one. Yeah? This F is fake one. So your F become negative F. If they tell you, oh, the focal length of this lens is 20 cm, then you put negative 20. Negative 20. Okay, understand that? So you know how to differentiate now? When to use the positive F, when to use the negative F. Okay? So even when you're calculating power, when you want to calculate the power of the lens, like power of my eyeglasses, same thing also one, got plus and minus one, got positive and negative one for the F, depending on what kind of lens you use. Convex, then positive. Concave, then negative. Okay? So this is for focal length lah. Okay, the next one, right, is the object distance. Object distance cannot be negative. Why object cannot be negative? Because object is always real. Okay? You want to look at something, right? That object must always be real, ma. Correct or not? You look in the mirror, you are the object. You are real, ma. Object cannot be fake one. So this will always be positive. This one you don't need to worry too much. Okay? Right. Next one, the V. Okay, so the V, right? Image distance, this one, you must see whether the image is real or virtual or not. Okay? Now, if you don't know how to differentiate what is a real image, what is a virtual image, okay, pay attention lah, Pay attention if you don't know how to differentiate. Now, this is our object. Okay? What is a lens supposed to do? The lens is supposed to let the light go through to the other side. Okay? And then form an image on the other side. This is what the lens is supposed to do. So if he did what he was supposed to do, then this is a real image lah. He's doing exactly what he's asked to do lah. This is a real image. Correct or not? Okay? Yeah? So this is a real image. But sometimes, right, even after the light go through already, you must get your image back on this side. Okay? You get your image on the same side as the object. Then, this is not a real image already, because the real image is supposed to be on this side. Yeah, the real image is supposed to go to the other side first. So this one is not real image already. This one is virtual already. Okay? So now you know how to differentiate. That's it. It's just like that only. It's just like that only. That's how you differentiate between real and virtual. Okay, now. Anyone still not sure? Like which one, when should I put positive, when should I put negative? Anyone still not sure? Okay, which one? For which part? The real and virtual, is it? Or which one? Do you know how to differentiate between the focal length? Positive and negative for focal length? This one can? This one can, Okay, so it's just this one only, Okay, so again, right now, I have an object on this side of the lens, correct or not? So the lens job is to let the light go to the other side and then form an image here. Okay, later I'll repeat the focal length one, okay? Yeah, the lens job is supposed to let the light go to the other side, form an image on this side, correct or not? So if he did his job, then it's real lah. It's a real image. He did his job already. Okay? But sometimes the image doesn't form here. Sometimes you must trace back and the image form on this side. Sometimes the image form back on the same side, which is not what you're supposed to do for lens, correct or not? The lens doesn't reflect light, the lens is supposed to let it go through, So if you see the image back inside the lens, then it must be a fake one. Yeah, if you see the image is like on the same side again, it's a fake image, it's a virtual image. Okay, now make sense or not? Okay, so you see the image on the opposite side, okay, positive. You see the image on the same side, okay, negative. How to know which image to draw? You mean like how to draw the diagram, is it? How to draw the diagram, is it? Or like how to know where the image will be? If you want to know how to draw the diagram, the for lens is fixed already one. The method is fixed already. Oh, where the image will be. Okay, so either the question will ask you to draw the ray diagram, and then you get the image first, then only they ask you to calculate. Or the question will straight away give you already one. Like for example, Like that. You see, straight away the question will give you already one. The object is here, the image is here. Like that. Then they ask you to calculate. Okay? Yeah. All right. So about the focal length, again, the focal length, right, depends on what kind of lens. If it's a convex lens, the light will pass through the F. So this is a real F. So my focal length positive. Okay? But for concave lens, the light does not pass through the F. Okay? The light does not pass through the F. So this is a fake F. This side also never pass through. Fake F also. So negative. Okay, now this I understand not for the focal length. Okay, can all right. Can. Okay, so yeah, basically that's it already. That's the main things you need to know about the calculation. Okay, so let's look at a few examples for calculation. Yeah, so we do calculation first. Then after this, we will do explanation questions. Okay, yeah, we'll do explanation questions. So we will start from page number 5. Page number 5 here. Okay, so let's just straight skip through to the calculation part on the bottom. Okay, first calculate the depth of the fish image given that the refractive index of water n is equals to 1.33. So when they give you the refractive index, you know you must use a formula for n. But which formula do you use? So it depends on what information they give you. They give you the depth. They ask you to calculate the depth. So you must be using this formula for depth, h over h. Okay, all right, now, the capital letter H is the real depth, okay? Real depth, which is this one, 0.5. You see the real fish? Fish. Okay, you see this? The real fish? Yeah, it's here, 0.5. So why the thing will keep on pop up? I don't understand. Okay, so 0.5 divided by H, the apparent depth is what we're trying to find. Okay, this one is equals to 1.33. Should write it like that. Okay, so calculate what is the apparent depth. 0.376. Okay, now you can see that this one is surely smaller than the 0.5, right? Because it must be further up, it must be shallower. I say already, everything that is inside water will look shallower. Yeah, it'll look like it is higher up. So that's why the depth is 0.376 like that. Yeah. All right, now next one. Calculate the critical angle of the water. Okay, so now you look at another formula, but this time the one with critical angle, which is 1 over sine C. Okay, 1 over sine C. So 1.33, 1 over sine C. This one you know how to calculate or not? You need to inverse sine one later. You want to find C, you have to inverse sine. Try calculate this one. Okay, so you see, I choose the formula based on what information they give only. Okay, you don't have to like, there's nothing much to think about one. It's just, oh, got this formula, then you do this or not. Got this formula, then you do this or not. Okay, Okay, 48.75, yeah. All right. Good. Very good. 48.75, and you put degrees. Okay, yes, you put degrees. Okay. Now, let's try another one. Critical angle. Okay, you can see again, very simple. Refractive index is 1.52. Calculate critical angle, n equals 1 over sine c. Then you just put in refractive index. Right. Easy, right? Okay, so I think for refractive index, I think it's not much of a problem already. So we can move on. Okay, let's look at the lens formula. Let's do the calculation for lens formula. All right. You look at page number 12. Page number 12. I mean, the question is at the diagram is at page number 11, but never mind. You just open page number 12. Okay. Okay, now here the object is placed, an object is at a near point of the eye, which is u equals to 25 cm away. You can see, they tell you u is what? The real image distance. They even tell you real image distance, you know. Okay, v is 2.5 cm. Eye lens has a minimal focal length when looking at objects that are near the point of the eye. So determine the minimum focal length of the eye lens. Basically, you're trying to find f. Okay, so 1 over f equals to 1 over u plus 1 over v. Okay, now 1 over f equals to 1 over 25. Object, no need to worry positive or negative because object cannot be fake. Object must be real. Okay, for the image, right? Now, let's say they never tell you it's real. Let's say they never say that the image is real. But you look at the diagram, this is a lens. This is the object. Where is your image? Your image is on the other side. You see or not? Yeah? Your image is on the other side. Object. Wait, why? This Ask Siri, can I turn off this Ask Siri or not? How to turn off this Siri? Oh, double H the bottom, double tap the bottom edge. Okay. Now it won't open already. Okay, very good. Okay, so if they never tell you that it's real, you can see object, lens, image must be real because it go to the other side already. It form the image on the other side. That's what it's supposed to do. So 1 over 2.5. Okay, 1 over 2.5. Now, when you do this, right, your units will be in cm, because you use cm for u and you use cm for v. Okay, so your units will be in cm. But if let's say later you want to calculate the power you must use meter. Okay, power you must use meter. You must remember to change. Here I just lazy to change that. You can also change to meter one. Can one. Change to meter, then your answer also meters. Still correct. Okay, still correct. All right, do you all get 12.5 cm? Is it 12.5? No, different. Never mind, you tell me what you get. 2.27. Anyone else got 2.27? 2.27, So you got 25 over 11. Then 2.27 lah. Okay, 2.27, All right, okay, can. So that's your F, type wrongly. It's okay. It's okay. Yeah, that's why we compare our answers, man. Then we know. Okay, so now they want to know what's the linear magnification. Okay, I didn't really teach about linear magnification just now. But I don't think it's something that I have to purposely teach lah, because linear magnification is such a simple idea. Basically, you want to know how many times your object is magnified, how many times bigger is your image, how many times smaller is your image, right? So imagine you are 150 cm, and then there is this mirror that makes you look big. So when you look in the mirror, right, you are 300 cm. So how many times you become bigger? Straight away, you can tell me, or teacher, 2 times. How do you get 2 times? You take 300 divided by 150. Right enough. Yeah, that's 2 times. So all you have to do is take the image height divided by the object height. Right? Image height divided by object height. But then, there is no height in this question. Yeah? There is no image height, there is no object height. Then how do you find the magnification? Well, it's very easy, because if let's say you have been magnified in the mirror, then wouldn't that mean the floor also has been magnified? Wouldn't that mean the walls also have been magnified? Yeah, everything, the cup, the table, the chair, everything also become big together. Okay? So if you have been doubled, then the floor must have also been double in size also, ma. Correct not? So your distance must have been double the distance also, ma. So instead of just using the height over the height, you can actually use the distance over the distance. Okay? The image distance divided by the object distance. Can also what? So then you just put 2.5 divided by 25. So your magnification is 0.1 times. So this one is actually diminished lah. This one is actually smaller. We still call it magnification. But this is a smaller. You make it smaller, okay? Kind of magnification. Okay, all right, let's try another one of this calculation. Oh, sorry, if it's smaller, do you put minus? Oh, no need. You just say, oh, my object has been 0.1 times. Just now it's like, my object is 2 times already, ma. My object got 2 times, ma. Now my object got 0.1 times. No need negative one. Yeah. It's just that the number smaller than 1, then we know it's become smaller already. Okay. All right. Let's see whether we have another one or not. Calculate the image distance. Okay, this one lah. Page number 17. Yeah, page number 17. Okay, so here, right, we want to calculate the image distance, which is V lah. Okay, we want to calculate the V, right? Now, 1 over F equals to 1 over U plus 1 over V. Okay, first of all, this F is negative. Why? Because this is concave. Yeah? Concave lens, they will never touch the F1. The light will be poing, 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 go out like that. It does not touch the F. So it's a fake F. So this is a negative F. Okay? And then, right, the image will also be negative one actually. The image surely is negative. This is from my experience lah. I know that concave lens only give virtual image. But you don't know, never mind. Let's say you don't know. In your exam, you don't know. Never mind, you just leave it. I'm trying to find V anyway. Okay, you just leave it. So now, let's put in some numbers. Okay, so what's the focal length? We don't have the focal length yet. We have to find the focal length. So how to find the focal length? You see this power? Yeah, this power. So we're going to do power is 1 over F. And since we know the F is negative, Yeah, so let's put it as negative lah. Okay. Actually, you don't want put also never mind, man. Okay, you don't want to put negative like that also never mind. Later you just put the numbers here. When you put in here, you put negative. Okay. So the power 25, 1 over f. F is 1 over 25. I believe is 0. That's 10. 0, that's 100. I believe it's 0.04 lah. Okay, 0.04. Now, I said just now, when you do for power, right, your unit will be meter one. The frequency unit is meter, frequency blood. The focal length unit is meter one. Only for power must be meter. So I can convert back to cm lah, which is 4 cm lah, huh? Okay, 4 cm. So now I can put in here, lor, 1 over minus 4. Okay, 1 over minus 4. Okay, then 1 over object distance from center to here, 4 cm as well. Okay, 4 cm, 1 over 4, plus 1 over v. Okay, so your job, find v for me. Minus 2, what is D? Oh, you mean this one, the 25D? That's the units for power. Units for power. It stands for diopter. Diopter. If you go to check your eyes, right, they will also show that in the result one. You go to check your eyes, let's say to check for short-sightedness or to change glasses. You ask him for the paper, for the result. When they give the result, you will see this also, like negative 0.05D, negative 20D, negative 200D. They'll tell you. Diopter. It's a power of a lens. How powerful is the lens? Yeah, so the V is negative 2, right? Okay. So if let's say the next question they ask you, what is the characteristic of this image? Then you know lah. This one is virtual. Okay? Negative is virtual. And then you see, the object is 4 cm away, but your image is only 2 cm away. So you know that your image is diminished. Your image must be smaller. Remember, bigger means further because the floor will also become bigger. Now it's closer, that means it's smaller already, diminished. And then it will be upright. This one how I know? Because U and V always together. Upright and virtual always together. If real, then it's inverted, but upright must always be with virtual. Okay? Can This one okay Real image can only be inverted. Inverted means opposite direction with the object. Upright image must always be virtual image. Okay, you know the different characteristic of the image. So either real versus virtual. Okay, and then inverted versus upright. Yeah, and then magnified, diminished, and the same size. That's for the size lah. Okay, so you need to know how to write the characteristics also of the image. Yeah. Okay, I guess that's about it already. I think most of the rest of the things, they are all the same already lah. Okay, you can try this one, page number 25. Page number 25, why don't you try this one? So we have a what is this? Concave lens. Okay, concave. So your F must be negative. Okay, negative. So 1 over negative 10 equals to 1 over 10.5. Oh, sorry. 10.5 is the height. Okay. Pay attention. You see, even I also make this mistake. They will tell you the object height, but they will also tell you the object distance. Okay? So make sure you don't use the wrong information. What you want is the distance. U and V are the distance, not the height. Okay? Right? So yeah. Image object distance is 20 cm. Calculate the image distance first. Yeah, calculate the image distance. So like that. Object is 20 cm. Okay? Then image is what? You calculate this V first. Okay, negative 6.666667. Correct? You check each other's answers. Negative 6.6667. Okay, then this is a virtual image lah. Okay, virtual image. So it will be here. This is an image. Okay, yeah. I know it's gonna be here because it's virtual mah. Virtual must be on the same side as the object. Okay, now what about the height of the image? Okay, the height of the image. Now, just now I said already, right? If you want to know how big or how small or how much you magnify, you want to know the magnification of the object. You can either use the height of the image compared with the height of the object, or you can use the distance of the image compare with the distance of the object. Correct now? I told you that just now. So can we just say that the image height, let's put it like this, the image height over the object height, this is the magnification is the same as the image distance over the object distance. Can we say that? Yeah? Since if I compare the height, I will still get magnification. I compare the distance, I will still get magnification. So wouldn't that be the same for both sides? Right? So then you can say the height of image over the object height is 10.5 cm. Okay? Image distance is 6.667. I don't need the negative because I just want to know the number only. Okay? I don't need to know whether real or virtual. Object distance is 20. Okay now. Anyone don't understand this, like where this formula come from? Anyone don't understand this formula? Okay, can I? Okay, so can you find the height of the image with this? 3.5. Okay, 3.5 cm. Yeah, it will be diminished lah. Diminish. Smaller. If it's a closer distance, of course, it's going to be smaller size. Okay, now. Okay. Anything else you want to know about calculation? This one you be careful. This one you must use this one. Image distance is from here to here. Not the 48. 48 is from here to here, okay? Image distance is here to here only. This one be careful. Anything else about you want to know about calculation? Anything else you want to know about calculation or not? Okay, can. No problem. Because I feel like the questions all the calculation question, I think the rest of it should be no problem already. You should be quite okay already because it's repeating only. Okay, so if it's okay, right? Now let's look at explanation. Okay, later we will do some explanation question. For example, like all this explain, and then we do this explain kind of things lah, huh? Okay, but I think before explain, right? Later we do. But I want to talk a little bit about total internal reflection. Because I notice a lot of people they forget about this thing one. Yeah, total internal reflection. Okay, so what is this total internal reflection? Okay, before we even know what's total internal reflection, you need to know that light will always undergo refraction, right? When it goes into like different objects, okay, when it goes into different density, because the speed of light change, then the light will bend, correct or not? The light will bend here, bend there. So that's a normal refraction lah. So let's say if the light shines like this, and then this is, let's say, air, and then water. Okay, then what do? You have a normal. Okay, then the light will bend like this, closer to the normal. This one everyone is clear, right? This one everyone is okay, right? Yeah. So no matter what, let's say this one like that, this one move up, then this one will be like bending a bit more lah, like that. Okay. If this one move down like that, then this one perhaps will bend a bit lesser lah, like that lah. Okay. This one no problem Okay. Now, if let's say your light goes from water to air, okay, your light goes from water to air, then it will also bend, but it will bend away from the normal. Because water is slow and air is fast. Okay, so you can see it bend away from the normal, right? So if let's say it's like this, then maybe it will go like this, okay? Yeah, but there is a very special situation when your angle is bigger than the critical angle. Just like I told you, everything got their own critical angle. Water got his own, diamond got his own, glass got his own, everything got his own critical angle. Okay? So, yeah, when the angle is greater than the critical angle, instead of going out as usual, instead of reflecting as usual, it will actually reflect back. Okay? It will actually reflect back. So this is total internal reflection. It can only happen from denser to less dense. From air to water cannot happen one. Only can happen from water to air, dense to less dense, glass to air, diamond to air. Okay? Right? So this is the idea behind a total internal reflection. Okay? All right. So now that you know this already, then we can continue lah, huh? Okay, so let's look at one explanation question first. Okay, let's start with this one. Page number 7. Page number 7. Since we are talking about total internal reflection already. Okay, so here we have a driver seeing an image of a cloud on the road. It's a hot, sunny day. He sees an image of a cloud on the road. Okay, the driver will actually see water. The driver wouldn't like see, wow, got a very soft cloud on the road. No, the driver will see water on the ground, like just a puddle of water. Because clouds are made of water, so they will see water. But when he drive over there, no water. Now, this situation is known as mirage. Okay? Mirage means you see something that is not there. Okay? You are seeing something that is not there. You are imagining things that is not there. That's called mirage. Only happens on a very, very hot day only. Okay? Only happens on a very hot day. All right, now, how does this phenomenon form? Okay, so while I explain, right, I will draw the diagram out for you because that is the only way that you can understand what I'm trying to say here. Okay? Because if I just do the explanation, you won't understand one. So I have to explain and draw at the same time. Okay? Now, the first thing to explain is this. Cold and hot air. So why does this only happen on a very, very hot day? Because, right, on a very hot day, air above the ground is hotter than air further up. Okay? On a hot day, air above the ground is hotter than air further up. Why? Because the ground is very hot. The ground is basically cooking the air that's above it. So the air here becomes very hot. But as you go further and further up, the air will actually be cooler and cooler because it's not being cooked by the ground. Do you understand? So let's call this hot, warm, and then cool, and then cold. Okay, you can see the different level. Hot is hottest and then getting colder a bit, then colder a bit. Okay? So that's the first explanation. Air above ground is hotter than air further up. Okay, now I need to have a cloud in the sky. Definitely, that's where the clouds are. So let me have a cloud in the sky first. Okay, if you want to see the cloud, I don't care where you see the cloud. You see the cloud here, I don't care. If you want to see the cloud, the light from the cloud must go into your eyes. Okay, that's how you see things. The light from the cloud goes into your eyes. Now, let's say there is a light coming down like this. Okay, let's say there's a light coming down like this. All right. Now, what do you think will happen when it goes between cold air and cool air? If you compare these two, this is cold, this is hot. Would you agree? Yeah, this is cold and this is hot. So you will undergo refraction actually. You undergo refraction. So I'm going to draw a normal here to prepare for my refraction. Okay, then I ask myself, where is it supposed to go originally? Or originally it's supposed to go here. But now, from cold to hot, the light will travel faster. Okay? Hot means faster. Cold means slower. So if it's faster, it must bend further away. You see that? This is the original. This is going to the normal. And then this is going away from the normal. Okay? Going towards, going away. Does this make sense or not? This first drawing? Which part doesn't make sense to you? Never mind. You let me know. Which part doesn't make sense? Which one? The first one or the second one? The second one, Okay, so you know that the light will go faster. This part you understand? Do you understand that the light will go faster when it travels from here to here? Yes, right? So when the light is faster, it will bend. Yeah, it will bend. That's called refraction. Okay? Yeah, that's called refraction. It will bend. Now, if it bends, right, it will either bend in or it will bend out. Whether it bends in or out, right, depends on whether you are fast or slow. The faster you go, the further away you run away from this normal. You see this 90-degree line? That's the normal. The faster your light travels, the further you run away. This is true for all waves. Water waves, light wave, sound wave, all the same. The faster you go, the further you can run away from the normal. Okay, that makes sense or not? So that's why you see, originally I'm supposed to go this straight one, like that. This is original straight one. But then now I must go further away from this blue color guy. Make sense? Okay, all right. So now you can imagine the same thing's gonna happen for the second level. Same thing's gonna happen here. I am going from cold to hot. Yeah, cool to warm is basically cold to hot. So when I go from cold to hot, I'm gonna go even faster. That means I'm gonna bend even further away. Look at this. This is my original path. I'm gonna bend even further away from the normal, like this, even further away. Okay? I want you to imagine that all this hasn't been drawn yet. All this does not exist yet. I want you to imagine. Yeah, even further away. Okay. This one can accept or not? This one? Yeah. Can accept, So let me explain this, Let me explain this. You say, when light travels from cold air to hot air, okay? When light travels from cold air to hot air, it bends away from the normal. Okay? When light travels from cold air to hot air, it bends away from the normal. Correct, right? Yeah. Now, next part. Here, I am going to draw another normal. Okay, I'm going to draw another normal. And now you are still going from cold to hot. You are still going from dense. Cold means dense. Okay, hot means less dense. That's the reason why hot is faster, because it's less packed, it's less dense. Okay, so now you will expect what? You will expect the light to go further away, correct or not? Even further from the normal, But if you have a look at this angle, this incident angle is quite big, right? Wouldn't you say? This angle is actually quite wide, quite big angle. So it's so big that it's actually more than the critical angle already. It's more than the critical angle of air. Now, you might be thinking, but teacher, what's the critical angle of air? How do I know whether it's more than or less than? Eventually, it's going to be more than, ma, correct or not? You see how he always bend away? You see how he's always bending away and away and away and away? So I don't care what's the number lah. Eventually, it's going to be bigger than the critical angle one. Do you agree or not? Because the angle is getting bigger and bigger and bigger. Eventually, at some point, it will be more than. So let's just say, at this point, it is more than. And what happens when it's more than the critical angle? It will reflect instead of refracting. Okay? It will reflect the light back up instead of refracting. Okay, now? Yeah? So you say, you explain, when the incident angle is greater than the critical angle. Okay, when the incident angle is greater than the critical angle, total internal reflection occurs. Okay, TIR stands for total internal reflection. This third sentence okay or not? Together with the drawing. Together with the drawing, this third sentence okay or not? Okay, can all right? Because I just need you to know what you're copying. You don't need to memorize this. I just need you to understand what you're copying only. Okay. Now, for the last part, human brain, stupid one. Okay? All humans are stupid. You are stupid, I'm stupid, all humans are stupid. When the light comes into our eyes, we never think about, oh, it comes from the sky, it undergo refraction, it go total internal reflection, come into my eyes. No. The brain always think light travels in a straight line. So the brain automatically thinks that the light came from here. So the brain will automatically think that the cloud is here. You understand? Yeah? The brain receives the light from downwards. So the brain automatically thinks, hey, the cloud is down there, giving me the light. So that's why he sees the image of the cloud. Okay? So you see an image of the cloud. An image of the cloud is seen on the road. Okay, right? Then like that, it makes a lot of sense, right? Yeah. If now that you see it explained step by step, it makes a lot of sense, right? But if I just tell you straight away, hey, actually the water on the floor is actually a cloud, it doesn't make sense to you, one. But now it makes a lot of sense, right? If you look at the explanation bit by bit. Yeah. Okay, all right. So let's take a short break. Okay, take a short break. If you want to go drink water, you go drink water. You want to go pee, go pee. You want to take a 5-minute nap, then you can take a 5-minute nap. We will come back at 3:16. Okay? Yeah, we'll come back at 3:16, right? Short 5-minute breaks lah. Okay? I'll see you in 5 minutes, Okay. Back already or not? Everybody? Okay, not? Back already? Already? Shall we go on to the next part? Next question? Yeah. Look at this one. Page number 9. These are also quite a common explanation question. Okay? These are quite common explanation question. Page number 9. The about diamond one. Why do diamonds sparkle more than glass? Okay, all right. So, in order to know why diamonds sparkle more than glass, right? You need to know how does the sparkling happen first. Okay, right? You can have a glass that is shaped exactly the same as a diamond. How diamond look like? Okay, you can have an exact same shape, exact copy and paste same shape. One is glass, one is diamond, but you will notice that the glass, right, it won't be as shiny one. Because why? Because when the light go in, it will go out. When the light go in, it will go out. Light go in, go out, right? So all the light go in, it'll just straight away go out only. But for diamond, when the light go in, right, it will do this ping, pang, pang, come back out. The light go in, it will go ping, pang, like that, come out. Ping, pang, ping, pang, ping, pang, pang, ping, pang, pong, pang, ping, pang, like that. You see or not? You see what happens or not? The light will reflect inside the diamond and then bounce back up. So that's why you think it's sparkling, but you are actually looking at the lights only. Correct or not? Yeah? You don't like diamond, you like the lights. Okay? If you buy a light bulb and then you stare at the light bulb, it's the same thing, man. It's same as a diamond. Okay? So why does the light escape from the glass so easily, but the light cannot escape from the diamond so easily? Instead, what is happening here? What do we call this? That the light cannot escape. It goes back. This is total internal reflection. Yeah? This is total internal reflection. It reflects inside the diamond. Okay. Now we know this is what happens already, correct or not? Total internal reflection happens more inside the diamond. So now we have to think, why? Why total internal reflection can happen more? You think about how does it happen now? Okay? Why just now, in this situation, why this one don't happen? Why this one don't happen? Why this one happen only? Is because the angle must be greater than critical angle. Correct or not? Yeah? This angle is smaller than critical angle. This angle is smaller than critical angle. This angle is bigger. So this one happened. So how can I make it happen more easily? How can I make the total internal reflection happen more easily? I have to make the C smaller lah. Correct or not? Yeah. Let's say this one, the C is 50. So if 30 degrees is not more than 50, 40 degrees is not more than 50, then 60 degrees, okay, finally can happen. But if let's say I reduce the number, I reduce to 20, then this one also can happen already. This one also can happen already. This one also can happen. Correct or not? So if you want it to happen more easily, then your critical angle must be very low. Okay? Your critical angle must be very low. And how do you make sure the critical angle is low? Or if the critical angle is low, right? What does it say about your refractive index? So you look at the formula for refractive index. N equals to 1 over sine C. Okay? If this number is low, this number will become high. Okay? Yeah, remember, you divide by a small number, you will always get a large answer. So that is your explanation to why diamonds sparkle more. You start by saying, oh, refractive index is high, or critical angle is low, or total internal reflection can happen, and then it will sparkle more. Okay, so let's start by saying the refractive index of diamond is greater than glass. Okay, the refractive index of diamond is greater than glass. Right? Then, as a result, or you can say the critical angle, just straight away say lah, the critical angle of diamond is smaller or lower than glass. Okay, critical angle is smaller than glass. Okay, then total internal reflection occurs easier. Okay, total internal reflection occurs easier in diamond compared to glass. Okay, because the light angle is it's very easy to be bigger than C, right? The I is very easy to become bigger than C because the C is small, the critical angle is small. Okay, so therefore light reflects inside the diamond before escaping. Okay, which causes it to sparkle more. All right, the light will reflect inside the diamond. Sometimes few times, like reflect like that. Light, you can say the light reflects multiple times, or the light reflects a few times inside the diamond before escaping. So it causes it to sparkle more. Okay, now makes sense or not? This explanation. This explanation makes sense or not? Yeah, yes, Okay. Yeah, if you're not done, you let me know, right? Okay, let's look at this one. Hmm, okay. All right. Now, for this one, right? They say there's a convex lens. Oh, sorry, this is page 11. Yeah, page 11. They say there's a convex lens used in a smartphone camera, and they ask you to explain how a sharp image is formed on the sensor of the smartphone camera. Okay, so basically they ask you, right? How does the convex lens produce an image? Okay, how does a convex lens produce an image? Okay, so you basically have to explain to them how do you do the drawing for convex lens. Okay, how you do the drawing. This is not a proper drawing. This is not the proper drawing that we always use to draw for convex lens. So you cannot follow that one. Yeah, you should follow this one. This one is more accurate. Okay, this is more accurate. So normally for convex lens, right? How do we do the drawing? Is when, let's say you have an object here. Yeah. Now the first thing that we do is we will draw a light ray. We will draw a light ray, okay, to the focal length, to the lens, and then this light ray, what will happen to it? This light ray will go to the F. All horizontal light will also go to the F1 because converge ma. Okay, so why does it bend to the F? This is due to refraction. Remember, the lens will refract the light. The lens will bend the light. Okay, so let's explain this first. Let's explain this first. So you say light parallel to the axis. Okay, this one is the axis. This one parallel, parallel to the axis. Light parallel to the axis refracts to the focal point. Okay, light parallel to the axis refracts to the focal point. Yeah. Okay, now another one, we draw center. Anything that goes through the center, all right, of the lens will not refract. Anything that goes through the center of the lens will just go straight through only. Okay, so you say light passing through the center of the lens. Okay, light passing through the center of the lens continues straight. Okay, light passing through the center of the lens continues straight. Okay, then you say the light rays, what do they do? After this, after you draw these two lines already, what do you need to do? You need to find where the intersection point is, correct or not? Yeah, the intersection point is where you have your image, correct or not? The light rays converge and intersect to form an image. Okay? Yeah, the light rays converge and intersect to form an image. Okay? Now, where do they intersect? Where do you think they need to intersect to become a sharp image? Where do you think they need to form the image to become a sharp image? They must intersect on the sensor of the camera. The sensor is like our retina. If you intersect on the retina, you get a clear image. So same thing, you intersect on the sensor, you get a clear image. That's why sometimes, right, when you turn on your smartphone camera, sometimes you try to take photo, it will become blurred. Okay, yeah, like let's say you have a camera and then you try to move it around, right? Sometimes you move and then the thing is blurred, but then suddenly it become clear again, correct or not? Or you move away, then something becomes blur, but then it becomes clear suddenly. It's actually your phone changing a different lens. Okay, nowadays most phones have more than one camera lens, correct or not? Let's say you have 2 or 3. So the camera will choose which lens is the most suitable so that the light will focus on the sensor. If it's a near object, it will choose another lens so that the light will land on the sensor. If it's a far object, then it will change to another lens also. Okay? Yeah, so that it can land on the sensor itself. So you must say the intersection point, occurs on the sensor to produce a sharp image. Okay, the intersection point occurs on the sensor to produce a sharp image. Okay, so this is how you produce a sharp image on the sensor of the smartphone camera lah. Basically just explaining how the light form the image only. Okay, so speaking of this forming image, you need to know how to write characteristics. Okay, characteristics of image, we got three things you need to write about. You got not? Characteristics of image. Okay lah, never mind. Okay, so characteristic of image, right? Basically got three things you need to talk about. Number one is real or virtual. Just now I teach you already, right? How to determine whether real or virtual. Okay, that's the first one. Number two is the size. You can talk about the size. Is it bigger? Then you call magnified. Is it smaller? Then you call it diminished. Or is it same size? Okay, is it same size? And number three is whether it is upright or inverted lah. Upright means same direction. Inverted means opposite direction. Okay. Now, for the image in the smartphone camera, first of all, right, it is surely diminished one. Surely diminished one. Because imagine you are trying to fit a real life object into such a tiny little gap. Correct or not? You're trying to fit a real life object inside a small camera like this, So you must make it smaller, The image must be smaller, much, much smaller than the object itself, So it's diminished, Okay, it's diminished. Okay, number two, the light needs to go past the lens and then land on the sensor. Right now, yeah, the light needs to go past the lens and then the intersection point, must be on the sensor itself, which means the image must be on the sensor. It's inside the lens. Okay, as in like on the other side basically. This is your phone, This is your phone. So the object is here. The light must go into the lens and then form the image inside the phone. So this must be a real image because it go to the other side already. It went through the lens already. So this must be a real image. And I told you just now already, real must be together with inverted. Real cannot be upright. Okay? Upright must be virtual. So real must be inverted. Okay? Okay lah. Can I? Okay, let's see whether got any other explanation or not. Okay, I think that's most of the explanation questions already. This one here. Let's try this one. Explain how to use concave mirror to heat up water in a container using solar energy. Page number 22. Page number 22. Okay, so basically, right, this is a concave mirror. Yeah, and I'm using it to heat up the water inside this container using solar energy. When I shine the sun, it will basically make this thing hot lah. Okay, it can even make it boil. Okay, so how does it work? Now, first of all, concave mirror it's curved like this, right? So concave mirror, it will everything that hits, right, it will go to the focal point. It will converge to the focal point, converge to the F. So you must tell them where to put this container. This container you must put on F. Okay, you must put on F, the focal point. Yeah. Now this is exactly the same if they ask you to explain for satellite. Right? If they ask you to explain for satellite, listen, this receiver, okay? You see, the right side, right? Okay. Okay, you see, the right side, this part, okay, this part is called a dish. This one is called a dish, a satellite dish, okay? This thing is a receiver. Because a lot of people keep thinking, hey, the whole satellite is used to receive signal. No, the only thing that can receive signal is this. That's why it's called a receiver. The rest of this is just a normal dish only. Okay? So the whole point of this design is so that we can put the receiver where? We can put the receiver in the focal point, in the F, so that all the rays, all the information converge there. You understand or not? So it's the same explanation one. If you want to explain the solar power kettle and you want to explain this satellite, it's the same idea. Okay, so you say the container is placed at the focal point F of the concave mirror. Okay, the container is placed at the focal point F of the concave mirror. Okay, next, when the mirror is pointed at the sun, okay, when the mirror is pointed at the sun, okay, then what do we say? We say all this sunlight or the sun ray. Now, when the sunlight comes from very far away, right, they will always be parallel one. Yeah, when the sunlight comes from very far away, we assume they don't come in like that. We assume they all come parallel. This is what we assume when things come from very, very far away. Okay? So you say the parallel sun rays, will converge towards F. Okay? Will converge towards F. So then what happened? All the sun ray will have heat, correct or not? So you say the heat energy is concentrated at the container. Okay? The heat energy is concentrated at the container to heat up water. Like that, lor. Easy, lor. Okay, so satellite also similar thing lah. You say the receiver is placed at the focal point, and then you say when the satellite is pointed towards the target, then you say all the signal will converge towards the F. Then you get a very clear signal like that. Okay? Yeah? All right. Any more? Let's see. Prism of length, calculation, focal length. Okay, I think that's all the explanation questions already lah, right? So we already master all the calculation already. We already master all the explanation already. So what else? I think the only thing left is the essay only, right? Yeah, it's an essay only lah. Or anyone wants me to do a bit of drawing exercise? You prefer for me to do drawing or for drawing? You need drawing. Okay, for drawing, right? You want to draw lens or mirror? Lens or mirror? I think maybe can do both lah. But okay, we start from lens first lah. Okay, we start from lens. So there's one here, page number 12. Okay, now again, the idea behind drawing, right, is actually you just need to know what the light do only. Yeah, you just need to know what does the light do. Okay, so like all horizontal light, all horizontal light. If you go to the convex lens, you know where does it go? You know where does it go? If you have horizontal light like this in the convex lens, where do they all go? Where do they all go? To the F to the focal point correct or not? Right? They will all go to the focal point one. So later when you do drawing, if you have a light that goes horizontal, you just draw to the F. You just draw to the F only, that's it. Okay? And if you have a light that goes through the F first, if you have a light that goes through the F, do you know what will happen to it? It will become horizontal. Same you shine from this side, it will go this way one ma. So if you go this way to F first, it will go horizontal one. Right or not? All horizontal will go to F. Okay? And then next one, anything that pass through the center, this one. Anything that pass through the center, just go straight only. Pass through the center, just go straight. Sorry, that one not center. Like that. Pass through the center, just go straight only. Pass through the center, just go straight. Doesn't matter where the light come from. If it pass through the center, just go straight. If it pass through the center, just go straight. Okay, now, can I understand this concept or not? Okay, so it doesn't matter where I put my object, it doesn't matter one. It can be here, it can be here, it can be here, it can be here, it doesn't matter. As long as all horizontal light ray go to the F. All horizontal light ray go to the F. Okay? Yeah? And then everything that goes through the center will just go straight. Anything that goes through center goes straight. Oh, why does pass through center go straight? Because right, when you pass through the center, okay, how to say this? When you aim at the center, right, the light actually goes in at 90 degrees one. Yeah, the light goes in at 90 degrees. Okay, all right. Let me draw a square example for you first. And then, let's say you have a square glass. Okay. If you shine your light like that, the light will bend. This is refraction. Just very basic refraction. Okay? You shine your light like this, the light will bend. Okay? Very basic refraction. But if you shine your light 90 degrees, exactly 90 degrees, you shine it exactly on the normal itself. This light won't bend one, This light will just go straight. Yeah, it will just go straight. And then go straight through. Come up. Because it's also 90 degrees. Here also 90 degrees. Go straight through. Okay? Do you understand? Yeah? Because there's no angle, so he doesn't need to bend one if there's no angle. Okay? So if you aim a light at the center of the lens, right, it will basically go in at exactly 90 degrees, even though it doesn't look like it. Because of the way we draw the lens, right, it's not perfect. But when you aim at the center, it will actually go in at 90 degrees. That's why it doesn't bend. Yep. Okay? All right. So now your problem is where to put the object. Most questions, they will give you the object. For example, like this one. They give you the object, no problem. Yeah? They give you the object, you see? No problem. But for this one, why they never give you, right, is because they want to know, do you know what is a magnifying glass or not? Yeah? They want to know, do you know how to use a magnifying glass or not? So when you use a magnifying glass, you don't hold it at your eye like that and then look at the object in front of you. No, don't. You hold the magnifying glass close to the object. Then only it will look bigger in the magnifying glass, right? Your object that you want to see must be right beside the magnifying glass. So your object has to be like within this space, within here, within this F. It must be very close to the lens. So it must be within this area. That's why it won't be far, man. For magnifying glass, it won't be far away. If it's far away, you cannot see anything, man. Okay, it must be near to the lens. Okay, then like I said, you just draw the thing that you know. You know that something goes straight the middle, something goes through the middle, doesn't bend. This one you know. And you know that something goes straight like that, horizontal, it will surely go to the F. These two you know already. Just now I already confirmed with you already. Okay? So now, find the intersection point. Right? This one getting bigger and bigger. Doesn't intersect. So it must be behind. But remember, your light cannot go backwards. Your light cannot go backwards. You can only say, oh, if I trace back, I trace back. Your real light cannot go backwards one. You can only draw these fake lines, fake light rays. Trace back. This is your image. The image will be here, the intersection point. Okay or not? Easy or not? Okay, this is how you draw. So let's say I just simply change another location. Let's say my object is here. My object is here. Then I draw the same lines only. I draw the same. Oh, horizontal must go where? Horizontal must go F. And then center, no need to bend. Then intersection, image. Image. Easy, right? Yeah. Once you know, actually you are drawing what the light do. It's not random lines one. It's not random lines. You are drawing what the light actually do. Then it's actually very straightforward one. Okay, so no matter where you put the object, the way you draw is the same one. Okay, now. Yeah, clear? This one clear? Okay, all right, now. If you look at this one for page 17, page 17. By the way, the F is here. You just label the F. Just now we already calculated the F. The F is at 4 cm. Okay. The intersection is where your image will be. Okay, where you have the intersection, right? That's where your image, you have to draw another arrow. You draw another arrow, that's image. Because this is object. Object is a real thing. Image is what you see. Yeah? All right, now, see, concave go out one. Concave doesn't go to the F one, concave go out one, go away one. Okay, go away. But how do you know whether this line will bend? You see the horizontal, I know it will go out, I know. But where does it bend? Is it gonna bend like here or here or here or here or here or here? it depends on the F also. Even though it doesn't go to the F, it still depends on the F. You see, you just aim the F at this line here, like that. Aim it. Okay, you see, I aim like that. I just aim only. Okay, then now you see, oh, the light will go like that. Okay, the light will bend this way. Yeah, you just use your F to aim. Even though it doesn't pass through, you still use your F to aim. Okay? Then the second line is the same line. Second line is the go through the middle line. Yeah, same line. The go through the middle line doesn't change one. Go through the middle line doesn't change. Still just go straight through. You see the intersection point here or not? Yeah, this one, intersection point. Okay. Easy, right? Now for lens, now you can draw all lens already. No matter where you put the object, what you are doing is the same one. The steps you are doing is the same one. Horizontal surely got something to do with F. Either you go to F or you go away, but you still aim from the F. Then the middle line, always just draw the middle line, the center, true center, nothing changed. Then that's it. That's your image already. Okay? Can I? All right, now I draw mirror. Okay, mirror. You need to know what it does first. This one, convex mirror. Can you imagine or not? Convex, like that, like a shield like that. Okay? You hit him, boing, 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 fly out one. Can you imagine or not? Fly away like that. Can you imagine? So that's how the convex mirror act like. Okay? So that means this line here, again, this horizontal line here, it must be toing, fly out, fly here, or fly here, or fly here, or fly here, or fly here. How? Horizontal line must depend on what? Horizontal line must depend on F. So your ruler, is it possible it go to this F? Is it possible? It bounce in like that? Possible or not? Not possible, ma. Correct or not? Just now we already say, ma. This one is pointing outwards, ma. Correct or not? So impossible you go to this F. So it's actually this F. It's actually this F. You aim from this F again. Aim from this F. Then you see, oh, it'll bounce this way, like that. You see or not? All horizontal line, surely you will go through the F1. Okay? Surely you go through the F1. Okay? Can? All right, now, we do this halfway like that, okay? You go to the concave mirror on page number 21. Concave mirror, page number 21. Again, concave, now concave, right? Everything go in, it will do what? Toing, 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 it'll bounce inwards one. Instead of bouncing outwards, it'll bounce inwards. So that means all the horizontal line, all will focus to the F. Just now we said already. So you see this one, I draw horizontal. Then confirm go to the F1, right? Just now we said already. Horizontal surely go to the F1. Yeah? So this is concave mirror. This one convex mirror. This one understand or not? The first line, horizontal one. This one understand or not? That's right. Easy, right? Okay. Now the second line is the tricky one. Second line is not through the middle anymore. So you must remember, only lens can go through the middle. Only lens you can actually shoot through the middle. But for mirror cannot. Mirror cannot shoot through the middle one. Okay? So for mirror, right, I want you to look for the C. You see this C here? C actually is double the F. You double this amount, then you get the C. Okay? C is actually 2F. So I want you to aim at the C. Basically, from the object, right, you just aim at the C only. Okay, let me draw the aim first. I just draw the aiming part. Okay, I aim at the C. Okay, now look what happened. Look what happened to the light. The light gonna shine. The light gonna shine, 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 shine. Okay, when it hit here, right? It hit the mirror, ma. What happened when you hit the mirror? You bounce back. But you bounce back exactly on the same line. That's what's special about the sea. You bounce back exactly on the same line. Okay, you bounce back exactly on the same line. That's the special thing about sea. Okay, you aim at the sea, you shoot the light, point, it'll bounce back to you. Yeah, it'll bounce back to you. Okay, now let me show you for the concave one. For the concave one, again, same thing. You aim at the sea. Look at the sea. Where's the sea? Here. You aim at the sea. Okay, let me draw the aiming line for you first. I draw the aiming line first. Okay, like that. Now, see, from the object, you go to the mirror first, ma. Go to the mirror, only can bounce back. You go to the mirror, then toing, it bounce back the same way. Bounce back the same way, like that. Bounce back the same line. Okay, aim at the C, you go to the mirror, you bounce back the same line. Okay, so now all that's left to do is find the intersection point. This one already got intersection point for you already here. This one intersection point here. Intersection point, this one already prepared for you. But this one don't have. This one you must find yourself because this one not intersecting. This one not intersecting here. So you must find yourself. You need to expand. Okay? Expand. Then listen. Listen intersection point. The lightweight. Oh, okay. No, this one actually no go through one. This one actually no go through. It's just that when they give me this line, I will treat this line as the mirror. Okay? When they give me this line, I treat this line as a mirror. So let's say just now that one, right? If they give me a line that looks like this, I will also stop at this line only. I will treat the line as a mirror. Okay? If they never give me the line, then okay, I draw until the mirror there. Yeah. So normally we will treat the center line as the mirror lah. Okay? If let's say they never give me this line, I will reach until the mirror only lor, then I come back lor. Yeah, never go through one. Actually, never go through one. Your line might be staggered a bit lor. Might be a bit different lor. Okay, but technically it won't be much difference one. It won't be much difference because if let's say this one you never draw until the line your image will still be here. Your image will still be bigger. Your image will still be virtual. Your image will still be upright. It's just a very small difference only. So you don't need to worry too much lah about that one. You don't need to worry too much. Yeah. Why the image behind the mirror? Because when you look in the mirror, the image is always inside the mirror, ma. Right? That's why it's fake one, ma, virtual one, ma. When you look in the mirror, the thing that you see will always be inside the mirror, which is this virtual image. Yeah, just like you look in the mirror, the you see is also your image, and it's also inside the mirror. Understand that? Yeah. So image behind the mirror is virtual one. For mirror, inside is virtual one. Because mirror not supposed to let the light go through. For lens, if it go through, it's real. It's a good thing. For mirror, if go through, it's fake one. Because mirror supposed to block. Mirror supposed to bounce back. Yeah. Okay, now any other questions or not? For this one for drawing? Okay, so I'm pretty sure the rest of it, right, you can actually do quite easily one. You can have a look. As for the essay, you just later on you just read the answer, then you see whether you can get it or not lah. Okay, I believe essay might not be. I don't think it will come out for your midterm lah for light and optics. Yeah, so yeah, for essay, that's why I didn't focus too much on it. Okay. Oh, your teacher tell you already for chapter 5. Wow, so good one. Okay lah, then yeah lah. So it won't be this chapter lor. So that's why I didn't focus too much on it. Okay lah, right? So if no questions, I will see you guys in normal class next week. Okay, I'll see you guys back in normal class. All right. So yeah, see you next week lah. Okay. Bye bye. Thank you. Okay, thanks for coming. Bye bye.